Okay, now that we've done our 3 trials, it goes to explain, think about different things you can change. So you can't necessarily change the angle because that means we physically have to change the pendulum, and there's no way that we could increase the angle and also can't go into the table to shoot. So we can't really change the angle. What you can do is change the mass of the marble. I do have a bigger marble that we could sit there and mass, and you could test it. You also could change your distance that you are from the pendulum itself. You could increase it or decrease it according where you are. For the most, we were pretty close, but in theory we could have gone either way with the distance. And we also could change the power, or the elastic potential energy. We were only at 1 peg. We could have gone to 2 or 3, so that means we were squishing the spring more. And that would increase our elastic potential energy, which would increase our kinetic energy, which then would increase our gravitational potential energy, which I'll show mathematically on the board in just a minute. Now, for the virtual students, I'm not going to make you sit here and test it out. I want you to sit there and explain what you think would happen, the hypothesis you pick. If you would like to test it out, come during tutoring, and we will sit there and test it out together, but I'm not going to make y'all test it out. But I am going to, a couple of things I'm going to make you do is solve for the velocity, and I'll step you on how to do that. You will need to find the height of the pendulum. That's why we found the angle. That part, stepping you through how to do that, is on the PDF that says help. So make sure you check that PDF. The first thing is, so it's momentum, right? So we got to think about what's happening before the collision and what's happening after the collision. So before the collision, we had 2 objects. We had the marble, and we had the pendulum. So the marble had momentum. We had the mass of the marble and the velocity of the marble. This was all before the collision. Again, you have to take the mass of the pendulum and the velocity of the pendulum into consideration. Now, what should have happened, and we're going to assume that it happened. When you talk about error, you're going to say that didn't happen. What should have happened is the marble and the pendulum should have become 1. It should have landed in there. So you have now 2 objects that become 1. Marble / pendulum. So you would take the mass of the marble plus the mass of the pendulum and see what velocity is happening, and that's after the collision. Now, there is an uploaded picture of the mass of the marble. Do we like grams? Hopefully you said no. We like kilograms. You will need to convert. So you just plug in the mass of the marble. We don't know the mass or the velocity of the marble. Our little pulling back 1 notch doesn't tell us how fast it's going. I gave you the mass of the pendulum. Again, look at the picture. Grams to kilograms, gotta convert. Before you launched it, was the pendulum moving? No. So what number goes with not moving? Hopefully you put 0. And then again, you plug in what you got, and this is what you're ultimately looking for. The issue is we have another unknown. We don't know the velocity of the marble. This is where energy comes into play. Let's think about what energies. We're still going to think about before the collision and after the collision. So way before the collision, we pulled back the spring, right? So we have some type of, so this is momentum up here. I'll change colors. And we'll jump to, this is energy. Okay, so before we did anything, we pulled back the spring. So that is some type of spring potential. Then, after we did the spring, it started moving. So that is kinetic. So we'll have that converting into kinetic of the marble plus kinetic of the pendulum. After the collision, our system becomes one, but at the very end, we have gravitational potential because it added height. Gravitational potential is our height energy. So if we're looking at this, so our equation for spring is 1/2 kx squared. Remember, our k is the spring constant, x is just how much it was squished, equals, kinetic is 1/2 mv squared. This is the mass of the marble, and this is the velocity of the marble, again, before the collision, plus, now, was the pendulum moving? We already said no. So if it's not moving, guess what our kinetic energy is? 0. Equals our gravitational potential. Our gravitational potential equation is mass times gravity times height. But in this case, our mass, we're not just dealing with one mass. Our objects combined. So we have to do the mass of the marble plus mass of the pendulum. We got to take that into consideration. We know gravity is 9.8 because we're on Earth, and then the height, that's what you saw for earlier in our little packet before. So you can actually use this equation. You would just use this part. You can use this equation to solve for your velocity. Because we have mass, we have mass, we have mass, we have gravity, and you have height. So we can solve for our velocity. Once we solve for our velocity, we can come up here and now solve for our final velocity. So it is technically a 3-step problem. You have to solve for your height first, which the packet that says help tells you how to do that. Then you have to use your kinetic energy, or your conservation of energy equation to solve for velocity. Then you have to use your conservation of momentum equation to solve for your final velocity. If you want to take it a step further, you could solve for your k, but I'm not going to make you because, one, you don't know, I didn't sit there and measure your how much it was squished, but you could take it a step further and do that if you wish. AP might, but remember, AP would give you that information.